Hello and welcome. This is the seventh problem of the series for CSIR UGC NET solution. So today I'll be solving a problem which goes something like this. A particle of mass m moves in one dimension in a potential Vx equal to kx power 4. At time t equal to 0, the particle starts from rest at x equal to a. For bounded motion, the time period of its motion is. So basically the potential is given and you need to find the time period. So this kind of problems are quite common in competitive exam, and even in interviews you might get similar problems. So how will you solve this? First of all, what you need to do is you write whatever information is given. So here it is given Vx equal to kx power 4, and what can we find from this? So if you do double derivative, what you will get is 12kx square at x equal to a. So if you write at x equal to a, this will be 12k a square, right? And we know that time period is equal to 2 pi root over m by d2v by dx2. For stable equilibrium, then it will be 2 pi m by 12k a square k. So it will be 2 pi by a root over m by 12k, right? And this is important part. So t is proportional to 1 by a, which means that the correct option will be option B. So let me recap. We have a potential, right? So the potential looks something like this, and at t equal to 0, the particles start from rest at x equal to a. So let this be x equal to a. So the particle starts from here, and so what happens with time? It will oscillate like this, right? So and what it says is the time period of its motion is dependent on what? So according to this, if you move the particle higher up, the time period will decrease. So basically t is proportional to 1 by a. This is how you need to understand the problem physically. So even if you are unable to solve the problem, you might guess what could be the possible answer. If you like our video, do give a like, comment, and also subscribe to our channel. Turn on the notifications so that you don't miss another upload. And I thank you all for watching.